identify whether this is a circle. And if it is a circle, find its radius and center and potentially graph it. So obviously there is only one term with x squared, so that is already completed. So there is nothing that I can connect to x squared to complete a square. It's already completed. But the other two terms, in other words, y squared and y, those need a third term. Can anyone walk us through the steps? What is the third term? Yes, please. Bailey? I'm sorry?
Plus 9.
Right, y plus 9. Can anyone say anything else? Yes.
You take the middle coefficient, like what would be the middle coefficient, you divide it by 2 and you square it.
And you get 9. Perfect. Excellent. So that's how we add 9 to both sides. This is how we find that number. Is that clear, everyone? Okay, perfect. So now these three terms will be here because we know that a binomial squared is
Trinomial.
exactly 3 terms. A binomial squared is, I know, I wanted to hear that the three terms, not 4. If I tell you 6, you're going to say 6?
Well, I mean, later.
Okay. Okay, it was just a trick. Okay, so a binomial squared is 3 terms. A binomial squared 1, 2, 3 terms. So can anyone give us the binomial?
1 plus 3.
Of course. What we squared to get this number. Absolutely. And it's plus because this is plus. Excellent. And then the right-hand side is 58. Now we identify the center and the radius. And it's done. And if you want to graph it, it would be somewhat difficult because of the square root of 58. So the radius is the square root of 58, and the center is?
0 minus 3.
Very good. Do you all agree with 0, -3? Everyone? Okay, perfect. Thank you. Okay, so I would like you to write this down. I will return your quizzes on Thursday, but I'd like you to write this down for both sides, both versions, because I want us to put this behind us for good. So obviously, this is the method I recommend. You use the method you like. X minus 2 minus 5 over x plus 2 minus 28 over x plus 2, x minus 2 equals 0.
There were 2 different ones.
Yes.
Like on one paper.
No, just no. Each student had one problem, but different problems.
Okay.
Yes. Any questions so far? This is the first line, right? First line after the problem itself. Second thing, plus or minus 2. Third, the least common denominator, which is x plus 2, x minus 2. Fourth, we need adjustments. Can anyone give us the adjustments, please?
X plus 2 and x minus 2.
Good, or nothing. Fine. So can anyone dictate this product?
X plus 2x plus 5x plus 10.
Awesome. Great job. Then, now we want this product with the minus, don't forget.
Minus 5.
Minus 5x minus plus 10.
How can it be minus 10? We have to distribute to both, right?
Mhm.
Clear? Okay. And then?
Minus 28.
Perfect. So then these two go away. Then we have x squared plus 2x minus 8 divided by x plus 2, x minus 2 equals 0. I meant to write a parenthesis. Okay. And then it's 0 over 1. What do we do? Very good, because we have 1 in the denominator now. Or you just say a fraction is 0 only when the top is 0. Same thing. X squared plus 2x minus 8 equals 0. And then we factor into
X plus 4.
x plus 4.
X minus 4.
Awesome. And then we have two options.
X negative 4.
Perfect.
And 2.
And 2. However, that's why we stated this. And we conclude that this cannot be accepted as a solution. So this is it. So please practice this as many times as you need in order to make sure that this is fully understood and we can move on from rational equations. Any questions for me? Yes, please.
Give our answer in a circle if you want us to also circle the restriction.
Oh, no.
Okay.
No, I just wanted to explain what I was doing, but no, that's fine. No, you don't have to circle. Okay, so here is version 2. Okay, so negative 4x over x minus 1 plus 4 over x plus 1 plus 8 over x plus 1, x minus 1 equals 0. Any questions so far? Restrictions, of course, not plus or minus 1. The least common denominator, x plus 1, x minus 1. And we need adjustments. For the first, the top. Very good. For the second. Right. And the last one, just 1 or nothing. So in this case, we have negative 4x squared minus 4x plus 4x minus 4 and plus 8. Do we agree with this?
Yes.
Everyone? Yes? We agree?
Yes.
Okay, then these two go away, and again, you can put over 1, or you can simply say a fraction is 0 only when the top is 0. So negative 4x squared and plus 4 equals 0. We always simplify the equation as much as possible, dividing both sides by negative 4. So x squared minus 1 equals 0, or x squared equals 1. Or from here, you can factor x plus 1, x minus 1, and we get x equals plus or minus 1. However, what do we conclude?
No solution.
Indeed. This equation has no solutions. It's a contradiction. We cannot find any x value or values that make the left-hand side equal the right-hand side. They don't exist. Okay. Next, I would like to finish this handout with one more problem. And then move on. Do you have other questions for me? Anything that you tried? Anything that you want to go back to? Anything? Anything? Any questions? Okay, Maeve, was that okay? Any questions on this? Any questions on this, anyone? Okay, perfect. Okay, so let's finish up this handout with one more problem. Or you can say, we can work on this at home. Can you work on this? They are all identical with the previous two. Let's just come up with a graph, with a figure, with a solid that we are dealing with, and then I'll let you finish it up at home. Is that okay?
Yes.
Okay, so let's read the problem from this handout. We are looking at modeling with equations, supplement, the last problem. As you've noticed, we basically worked on similar triangles, the same situation here. It's a problem that you will encounter in calculus. So, very similar problem, okay? So, let's see what they want. Let's come up with a figure, and then we can work on it at home. Is that okay? And then you'll let me know if you don't get the answer, whatever the answer is, whatever, I'm assuming it's this, then please bring it to class, we'll work on it. So, expect something like this on the first test. So, this is very important. Okay, so let's take a look and read the problem. A watering trough is 10 feet long, and in its ends have the shape of isosceles triangles. What is an isosceles triangle? It's a triangle with all three angles the same and all three sides the same. Okay, so this is problem 3 from supplement. on modeling with.
Shouldn't that be equilateral triangle, which you just stated? Isosceles.
Oh, yeah, isosceles. Yes, of course. I was thinking about. Yeah, right. Okay. Thank you very much. Yes, of course. So this is how it looks like. Thank you. My apologies. So this is how it looks like. So these two sides are equal. This is, they said, 10 feet long. And they have the shape of, yes, you're right, isosceles. I was thinking of equilateral. The triangles are 3 feet across at the top. So this measure here is 3 feet. And have a height of 1 foot. So the height on this side, so this is the height, 1 foot. And this is the top of 3 feet. If the water is 5 inches deep, okay, so here's the water, and this is 5 inches. Careful. We either keep everything in feet or we keep everything in inches. We know that 1 foot is 12 inches, so we can say now that the figure is the height is 12 inches. This is 5 inches. And this is 3 times 12, which is 36. So in this case, we have everything measured in inches. If the water is 5 inches deep, what is the volume of water in the trough? So we want to determine if this is the 5 inches, we want to determine the volume of water right here. So let's get this one started because I want to explain something. Let's say I have a box. I create a box from this handout. And here's my box. I folded the sides, let's say 2.5 inches or 2 inches, whatever you want to say, right? And I want to determine the volume of this box. It's an open top box, and I want to determine its volume. Here's one option. Area of the base times the height, right? So area of the base times the height will give us the volume. So the volume of air in this room, right, or the volume of this room. Area of the base times the height. Also, area of the base times the height. It doesn't really matter, right? I can say area of the base times the height, or area of the base times the height. I'm still going to get the same volume. Area of the base times the height, or area of the base times the height. I'm measuring the same volume in 2 different ways. However, in this case, the easiest thing to do is what? How do I determine the volume of the fluid or water in this? The best thing to do is area of the base times the height. Because I really don't have the area of the base times the height. It's better to consider the area of the base times the height, instead of the surface of the water times the height, because I don't know how to measure that. But if I have the area of the triangle times the height, then I can easier determine the volume. Is it clear what I'm saying? Do you see it? It's okay if you say I don't, and I'll explain it again. Is that clear? So, yes?
I see what you're saying. How are we going to find the area? So are we only going to find the area?
I have the length,
All right.
right? I only need to determine this area,
Yeah.
and then times the height. It's like determining this area times the height, instead of determining this area times the height. Is that clear why it's the same? I could say, let's find this area, and then times the height. But it will be more difficult. Okay? I still have to determine this measure anyway, because I have to find the area of this piece. I have its height, right, which is 5 inches, but I don't have this anyway. I still have to determine it. And I will have to determine it using what? Similar triangles anyway. Ready? So I need, for similar triangles, let's measure this. And we know what it is. Everything is in inches. What is it? Very good, 18 inches. I know this piece which is given to us as 5 inches, and I know this piece which is given to us as 12. I am asking myself how to get this piece. Without that piece, I cannot determine the area of that triangle. Is this better? Okay, so we start with the common angle. We're going to call this, how do you want to call it? It doesn't matter. X, Y, Z. Perfect. So the opposite side in the small triangle of the common angle. What do I write? Over 18. Excellent. So now these two angles are identical. In the small triangle, the opposite side of this angle in the small triangle. 5. And the same angle in the big triangle. 12. Now I use, this is a proportion, so we cross multiply. So then 12x equals 5 times 18, and x equals 5 times 18 over 12. You may ask yourselves, why didn't she multiply? It's because I want to simplify. By 6. So this is 15 halves. So x equals 15 halves inches. So if I have this piece that is 15 halves, how much is this piece? 15 halves plus 15 halves is 30 halves, which is, of course. So now I know that that triangle has 15 inches at the top, and it has a height given to us in the problem of 5 inches. Do I have the area of the base? Now, base times height divided by 2, and that's the base of the volume of the solid. So can anyone give us this area? Which is this area here? 15 times 5 divided by 2, area of the base, the area of a triangle. Base times height divided by 2, multiplied by 10. That will be the volume of water. Do we agree with the steps? Do we understand what we just did? Yes, please. Flynn?
Question. Since we calculated the area of the triangle in inches, does it matter that we're multiplying by
Everything will be in inches.
I know, but we're multiplying by 10 feet.
I will change that, of course. I can multiply feet and inches. So now the volume of water equals the area of the base, which is the triangle, multiplied by the length, which is 10 feet, multiplied by 12, which is 120 inches. So the volume of water is the area of the triangle times the length of the trough, which is 10 feet, but 120 inches. So the area of the base will be 15 multiplied by 5 divided by 2. This is the area of the triangle, considered as being the base, times the length or the height, which is considered 120. No, I'm not going to multiply because I prefer to simplify. And now I have 15 multiplied by 300, which is 45 and 2 zeros. Measurement unit. Nothing makes any sense without measurement unit. Yes, perfect. It's volume. We multiplied three measurement units, in other words, so this is indeed cubic inches. Any questions? I thought it was useful to go through the entire problem together. Is this clear? Of course, you can change it into cubic feet if you want to. It doesn't matter. Any questions on this problem? Any questions? Okay, before we continue, so let me show you, I'll show you because I also show myself, as I mentioned, I never taught it from this book. So we have completed models with applications and supplement modeling with equations. We have completed this. We looked at several problems from 2.3 before we completed the supplement. And now, luckily for us, we already completed this a long time ago. Yeah, last week. And now we have to continue with other types of equations. Before we do this, however, I don't want to wait. They put the supplement on absolute value here, and I prefer doing it now. So here's the supplement on absolute value. Wait, sweet, and I swallowed it. What's the tracking? Oh, it's right here. Here it is for you. Yes, no, but not the one. Here it is. I got it. Okay. Absolute value problems to prepare for calculus. So this is our next step. So feel free to read this. I'm going to explain what this is all about. But if you prefer or if you'd like to read this and see other methods, please do so. Okay. Okay. Absolute value supplement. Absolute value supplement. Okay, we've all seen something like this at some point in math classes. What does it mean?
Absolute value.
Yes, this is the absolute value of x, which also represents the distance from x to 0. So if you say the absolute value of 3, what will the answer be? Very good. And it means this distance, 3 units. If I ask you the absolute value of -2, what will you say? 2, which means this distance of 2 units. So as you see, the answer is always positive unless there is a minus in front. If I want to change this, it will be the absolute value of 3 with minus in front will be -3, correct? Agree? Okay, perfect. But these are very clear because we use numbers. I'm interested in this expression. And what are the options for this expression? In other words, we're trying to come up with a definition that works for any situation, in any situation. So this, I don't know what x is. But x cannot be anything else but 2 things. It can be positive or negative. So if this is positive, I can remove the absolute values, symbols which are not grouping symbols. So if I have a minus in front, you cannot just distribute it. This is not a grouping symbol. This is totally different. It's not parentheses, it's not brackets, and it's not braces. It's totally different. It cannot be treated as a grouping symbol. So if x is positive, I can remove the absolute values, and I have to write an expression. If x is negative, I remove the absolute values, and I write something else. Anyone remembers how to simplify this without absolute value? This is called the formal definition of absolute value. Formal definition of absolute value. So the absolute value of x So there are, again, two possibilities. If x is positive and if x is negative. In positive, we also include the 0. So if x is positive or 0, the absolute value of x will be replaced always by,
Can you repeat that?
say it again.
Can you repeat that?
Yes, yes. So if x is positive or 0, the absolute value of x will be replaced by just x. If it's positive, right? It's just x. We agree? Perfect. I don't need the absolute value. If x is positive, this quantity, this expression can be replaced by x. But what about this is negative? When it's negative, I have to replace it by something that will eliminate the absolute value. That's the purpose, to eliminate the absolute value. I cannot work with this. I'm stuck. If I have the absolute value and I can replace it by something that it equals to, I can continue. So what would be the second option when x is negative? Something without the absolute value bars. What do you think? 0 is here. Very good. Thank you so much. Dante, right? Very good. Of course. If x is a negative number, this expression can be replaced by this expression. This we can work with. This we cannot. Now, remember, this is just a definition. It's very rare that you will get just plain x. So now let's talk about it. And please tell me what to replace any expression with x. Any expression in x by. Anything. It can be anything. It can be 2x minus 5. It can be x squared minus 3x. It can be x cubed minus 5. What do I replace it with? All you have to do is mimic. This is this, is this, is this, is this, is this. That's all I want you to do. Just dictate and I'm going to write it. Exactly. If the expression, these are all the same, is greater than or equal to 0, then? Exactly. If?
Expression
Exactly.
is less.
Ah, awesome. Once we understand this mechanism, we will never have any difficulties with all this. This right now looks gibberish, doesn't it? You will see it's not going to be a problem. But we have to understand this definition. So notice the same quantity is presented 5 times. 1, 2, 3, 4, 5. Identical. The only change is right here. Okay, moving on. Let's choose a problem. We are given these expressions. We're asked to simplify without the absolute value. So please choose because several of them will be homework, right? So please choose whatever you want. Let me choose the first one and then you choose this next. I would like to choose 8, which is, by the way, the most difficult one. You want 6? It's, that 6 is the same thing, but it's 8 is more difficult. So let's do 8. Maybe I should not start with the most difficult one. Let's start easy with a simpler one, and then we'll look at 8. I think it's a good idea. So let's try 4 first. 4 and then 6, and then 8. Okay, so we have the absolute value of x plus 1 minus 3x plus 1. Now, remember when I torture you with that question, a binomial squared is? Very good, thank you. I'm going to torture you with this type of question. No, okay, I take that back. So, every time we see the absolute value, unless clearly specified x, how many options will you have? Look at the definition at the top and say, whenever I see an absolute value with x in it, I know I'm going to have to write how many options? Right. So always remember, this expression is a complicated expression. You will have two options because this portion has two options. Okay, so let's start with the absolute value of x plus 1. Please mimic this. Do not calculate anything and just tell me what to write. For everyone to see as the first step. And I'm ready when you are. Very good. If
X plus 1 is greater than or equal to 0.
excellent. Do not forget to put parentheses. If
Negative x plus 1.
I didn't say that. I said that these, all five, be very careful, all five are identical. 5 identical pieces.
X plus 1 is less than 0.
Right. So I know it's a trap in there when you see that minus, you are tempted to carry that minus over there, but no. 1, 2, 3, 4, 5, always count till you get used to it. Count 5 identical quantities. So then you will say now that you have x plus 1 for x greater than or equal to negative 1. Do we agree with the first step? Yes, everyone?
Oh, yeah.
Okay. And then negative x minus 1 for x less than negative 1. One thing I would like you to notice is when you solve this inequality, you never need to solve this one. If this is greater than or equal to negative 1, this must be the other side. If this is less than or equal to negative 1, this must be the other side. So do not waste your time solving or trying to solve the second inequality. Once you have the first one, the opposite must be the second one. Okay, so from our expression, we only simplified this piece. But there is nothing else I can simplify because negative 3x plus 1 is negative 3x plus 1. So now this whole thing, this whole expression, let's write it one more time. The absolute value of x plus 1 minus 3x plus 1 has two different options. Obviously, one option for x greater than negative 1 and the other option for less than negative 1. Why? Because the absolute value of x plus 1 has two options. So let's construct this together. The absolute value of x plus 1, absolute value of x plus 1 minus 3x plus 1 is?
X plus 1 minus 3x plus 1.
Right. And the other option would be, careful,
Negative x minus 1 minus 3x plus 1.
that's it. So we have x plus 1 minus 3x plus 1, bless you, negative x minus 1 minus 3x plus 1. Of course, it's not done, but it's almost done. We only have to combine our terms, and that's it. Yes. Questions? Anything? Elmer, go ahead.
Where it says negative 1x minus 1,
Yes. It's the second piece. I have to copy it because this is this. So I'm here now. So this piece has two options. When it has the first option is this. When it has the second option is this.
provided the,
I can't touch this piece. This is carved in stone. I cannot touch it.
no, I was gonna say like, why is it minus 1 and not plus 1?
Because I have to distribute negative 1. I
Oh,
cannot
right, that's
distribute
right.
negative 1 to one term without the second.
Okay.
Clear, everyone? Okay, perfect. So, finally, the absolute value of x plus 1 minus 3x plus 1, and this is final. Can anyone dictate a final, please?
2x plus,
Negative 2x plus 2, yes. Awesome.
Negative 4x.
And negative 4x when x is less than negative 1. Thank you, Ryan. Extremely important. This is what I'm doing with my calculus class. So, being able to simplify absolute value expressions. Okay, so let's look at 8 now. Anyone questions here, please? Anyone questions? 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 Okay. I know I sound like a broken record, but I just don't want you to feel I don't want you to be shy. I don't want you to feel that you shouldn't ask. I don't know. I don't want you to think that it's a silly question at any point in time. Is that clear? Yes, please.
So for like the x less than minus one, is there no like less than equal to?
I cannot have two. Very good question. I cannot have two equal symbols. I can only have one equal symbol. If you want to, it's okay. If you want to erase it from here and put it here, but not in both. Very good question. Yes, Michael?
It just makes sense.
So you cannot put it in both. Good. Okay, so finally let's look at 8. Any question? So 9 minus x plus the absolute value of 3x minus 5. Well, I have to say that this is way more involving. Can anyone say why? Why am I saying yes, Michael?
Would it have 4 options?
Well, exactly. However, we will still end up with 2. And you'll see why. Or 3. So initially there will be 4, but they may collapse into 3. We'll see in a moment. And I'll explain why. Okay, so how do we start? Yes, Imran, go ahead. Any questions?
No.
Okay, so how many options does this piece have? How many options does this piece have? We have to start there. We are not putting it together before we analyze each and every absolute value by itself. So 9 minus x, do not calculate anything, do not jump into conclusions, you will see in a minute why. So please just give me the first step.
9 minus x is 9 minus x is greater than or equal to 0.
Perfect?
And negative parentheses 9 minus x, 9 minus x, less than 0.
Exactly. Let's simplify this fully and then we go back to the second one. Careful how you solve this inequality. Let's take this inequality aside. 9 minus x greater equal to 0. I personally prefer the variable on the left. It doesn't matter. It's up to you. So I'm going to move 9 and it becomes perfect. And now be very careful because we either divide or multiply by negative 1. And we get exactly. That's why I said do not jump into conclusions. So from here, we will continue with 9 minus x for x less than or equal to 9. And negative 9 plus x, do not solve the second inequality. You may make an error. Bless you. You know exactly what the second inequality is without even solving it.
Greater than 9?
Of course. Because if the top one has less than or equal to 9, the bottom one must have the other side. There is no question that it has to go the other way. So indeed, x greater than 9. So for now, consider this done. It's fully simplified, but it's not enough because I have another one to look at. So let's continue with the other one, and please dictate what should I write. So I have the absolute value of 3x minus 5, and please give me the 2 options. Do not calculate anything. Write them first till you get used to this, and then you'll be able to do it without writing so much. So first option is 3x minus 5. When 3x minus 5 is, that's okay. It's my handwriting, my apologies. I stand and it's not perfect anyway. Perfect. And then negative 3x plus 5, I can already distribute. When 3x minus 5 is less than 0. So now we have 3x minus 5. I have to solve this. Remember, we move 5. We move 5 and we divide by 3. Move negative 5 to the other side, it becomes positive, and divide by 3. So x greater than or equal to 5 of 3, and this is negative 3x plus 5. For x less than, do not look, do not solve, do not do anything.
5.
Okay, so now we are trying to put these two pieces together. We completely simplify the first absolute value. We agree?
Yes.
We completely simplify the second absolute value. We agree? Okay, now we have to put everything together in order to simplify this expression. So let's use the following table. X is the variable in the problem. 9 minus x is the first absolute value in the problem. The absolute value of 3x minus 5 is the next in line. And the last row is exactly what I'm interested in. I'm not interested in this. I'm not interested in this. But I'm interested in 9 minus x in absolute value plus the absolute value of 3x minus 5. Of course, x being our variable, it can be anything, any real number from negative infinity to infinity. So now my question is, let's go back to the two simplified expressions. Can anyone tell us which key x values I have to have in the table right here?
9.
Why? Because something major happens there. What? That expression changes from 9 minus x to negative 9 plus x at 9. And something major happens at 5/3. The second expression changes from this to this at 5/3. The numbers have to be in ascending order. Which number is the first? Of course. And the next one is 9. Please remember they have to be in ascending order. Now, let me know if you see with me 3 subintervals. One between negative infinity and 5/3. One between 5/3 and 9. And the last subinterval between 9 and infinity. We agree or not?
Yes.
Okay. So in the first subinterval, between negative infinity and 5/3, 9 minus x, or maybe I should explain differently. To the left-hand side of 9, I see 2 subintervals, but the absolute value of 9 minus x is 9 minus x in both. 9 minus x, 9 minus x. What happens beyond 9? To the right-hand side of 9, that expression can be replaced by, this expression can be replaced by negative 9 plus x. In this table, I'm not inventing anything. I'm just summarizing what I found so far. So that says, to the left-hand side of 9, you can replace 9 minus x as many times as you want. It doesn't matter by 9 minus x because that's what it is. But to the right-hand side of 9, that expression can be replaced only by negative 9 plus x. So now, I need to do the same thing for the second one. Let's read what this means. The absolute value can be replaced by 3x minus 5 for any number to the right of 5/3. To the right of 5/3, I'm going to write 3x minus 5, 3x minus 5. And to the left of 5/3, I'm going to write negative 3x plus 5. Again, I'm only summarizing the information in this table. So obviously, the final answer will have 3 different portions. One portion for x values here, the second portion for x values here, and the third for x values there. Luckily, I have the sum. All I have to do is add these terms and get the answer. Sum. Add these terms, get the answer. Add those terms and get the answer. So on the first subinterval, can anyone add these terms up? We don't have to change symbols, nothing. Just add them up and tell me what to write. Negative 4x plus 14 indeed. That's the first piece. Awesome. In the middle, please, anyone add up?
2x plus minus 4.
Very good. 2x plus 4. Excellent. That's the second piece. And now finally.
4x minus 14.
Good. So, 9 minus x plus 3x minus 5 in absolute value has 3 possibilities if, and please tell me what to write. You can only put the equal symbol once, anywhere you want, but only once. So, obviously, the first piece is negative 4x plus 14, the second piece is 2x plus 4, and the last one is this. But now the if. If means, where's x? What territory? So let's see the territory. The first one. Very good. So now I have this. If I put the equal symbol there, then I can no longer put it here. Perfect. And then this must be greater than 9. So you understand this is where they come from, right? This, and this. To the left-hand side of 5/3, in between 5/3 and 9, and to the right-hand side of 9. Is this clear? Any questions?
Earlier,
Yes.
I was. It was on the absolute value of 3x minus 5, and you have the two different solutions.
Options? Yes.
I didn't get the same solution.
Are we talking about this one?
Yeah.
Okay.
Yeah, I didn't get what do you have? X is less than 5/3. I got x is greater than 5/3.
On the second one,
So yeah, how did I get that wrong?
because you solve this instead of solving that, the original one. And that's what we said. We are not solving this. We are solving 3x minus 5 less than 0.
Could you show me that again?
Yes. So you solve this less than 0 with a minus instead of solving the original one.
I mean, could you just like work it out?
Yeah, but is it clear? So just remember, you are not solving here. First of all, you shouldn't be solving this ever. Ever, ever, ever. But if you do not solve it with minus. That's my point, okay? Is that clear so far?
Okay.
Okay. So now you want to solve this inequality, correct? So you move 5 and divide by 3. And you still keep the inequality symbol.
So it's only if you're solving.
You
right
cannot
side.
solve that. That's my point.
No, I'm saying on the right side. The only reason you would flip the inequality sign. is
Only when when I have to multiply or divide by a negative number. But here I'm not dividing by a negative number. I'm only moving 5 and divided by 3. Yes. Is that okay? Kill?
Yeah.
Other questions? Anyone? Yes, please.
How x is less than equal to 9?
Here?
Uh,
You mean here?
like when you get like x less than equal
From the
to
beginning?
Yes, from the beginning.
You mean here?
Yes, ma'am. Right there. X less than equal
So 9 minus x greater than or equal to 0. You move 9, it becomes negative 9. You divide both sides by negative 1, and you have to switch the inequality symbol. When you multiply or divide both sides by negative 1, you have to switch the inequality symbol. Okay, let me give you an example on that. Was that the question? Okay, very good. So look at this. Is 2 less than 10? Is that correct? Let's say I decide to multiply both sides by negative 1. Can I still keep this? Is negative 2 less than negative 10?
Right.
You understand? We have to switch the inequality symbol every time we multiply or divide both sides of an inequality by a negative number. Everyone? Everyone? Yes? Okay. So what I recommend, so we can move on, I recommend just do a couple of problems. Yes, please.
So how did you get me the if x equals whatever, the very last step that you did?
This is on this interval. This is on this interval. This is on this interval. Is that okay?
I mean, like, where you wrote if x.
So negative
Oh, you
4,
wrote in black.
negative 4x plus 14 is on this interval. And I copied it here. Less than or equal to 5/3. This is on this interval, so I copied it here, between 5/3 and 9. This piece is on this interval. I saw that, just 1 second. And it has to be to the right-hand side of 9. I just copy them from the top. This is for this interval, this is for this interval, this is for this interval. You just have to express it somehow. And we express this interval as greater than 9. Is that okay? Yes, please. Hold on.
In the last answer, like minus 4x plus 14, you said x is less than and equal to 5/3. How do you know like it is less than and equal? Like can like if x is less than 5/3?
You mean here?
Yeah, the one about that.
This one?
Yeah. So is it less than and equal?
Before we selected this piece, I said, put the equal symbol anywhere you want, only once. So if you don't want to put it here, you can put it here, but not in both. It doesn't matter where. If you want to put it here, fine, but not in both. It doesn't matter where. Was that the question? Where to put the equal symbol? Anywhere you want, only once. Yes, who was next? Hold on. Robert was next.
So I guess that was the question he had, because the answer on the back has x is less than 5/3, and then
You can put it, the equal symbol, you put the equal, they are all the same.
You wouldn't mark it wrong there.
No, it doesn't matter. It does not matter. You can put the equal symbol anywhere you want, but just once. Yes.
And I know you said just one, so can you please explain in the second interval why it's also, yeah.
It doesn't matter where you put the equal symbol. As well as for 9, you put it only once. So it can be less than, and here greater than or equal to. It doesn't matter. And why we chose that? Because it's right here in between.
Well, like why it's also, x is less than or equal to 9, when we also have above it x is less than or equal to 5.
Okay, so you don't want it here but want it here. That's fine. If you don't want it here but want it here, it's fine. As long as it's just one time equal symbol for 9 and one time equal symbol for 5/3.
Oh, so it's one for.
One for 5/3, you cannot have two. It will not be a function.
Okay, I thought you meant like once, like total, but it's
No,
one for 5/3.
No. One equal symbol for 5/3 anywhere you wanted it to be, and one equal symbol for 9 anywhere you wanted it to be. Yes, Ewan?
And if we have like 3 or 4 intervals, in case of 4 intervals, can we put 3 equal signs? Like we get 3 solutions. Like
You cannot. No, you cannot have more than something in the middle and 2 numbers on the sides. You cannot have 4. There is no such thing.
Like we can't have
No.
intervals.
Any interval is between 2 numbers,
Okay.
not between 3 numbers.
Yeah.
You cannot do that. It doesn't exist. So is it clear? Only one equal symbol for 5/3 and only one equal symbol for 9, anywhere you want, but just one. But it has to be at least one. I mean, one, exactly one. Good. Very good questions. Anything else here? Anything else? Okay, so it doesn't matter. So the answer is the same if you put the equal symbol here and no equal symbol at all here. You can have the equal symbol here, like this in the middle, and here greater than or equal to. It doesn't matter as long as you have one equal symbol for 5/3 and one equal symbol for 9. Better? Everyone? Okay, so what I recommend for next time, for Thursday, please just do 2 problems. I am thinking of number 5 and number 7. Just these 2 for now. 5 and 7, homework for Thursday. From this supplement, number 5 and 7. And check the answer, please, from the absolute value supplement. Okay. So now I would like to continue with equations. Other types of equations. There are a lot of other types of equations. So this is section 2.6. So we are here. Let me show you again. 2.6 other types of equations. So I'm going to start with a few problems from your book, and then look at this supplement with how I'm going to show you how to solve an equation with a graphing calculator. So first we're going to select a few here, and let me list